For this video, we're going to be discussing direct variation. So what is a direct variation? Well, direct variation is just a relation in which two variables are directly proportional. And direct variations are represented by these equations. Y equals kx, and y divided by x equals k. And k is just some constant number, and it's known as the constant of variation. And it's really just another name for slope. So you can think k is the same thing as m. All right, if we think back to slope-intercept form, y equals mx plus b, well, I can say y equals kx plus b. All right, k and m, they're just different terms we use, or different letters we use for slope. Now, if we look at these two equations, you should notice that they're really the same thing. This is y equals k times x, and this is y divided by x equals k. All we did to go from here to here is we said, well, y equals kx divided by x divided by x, y divided by x equals k. So the way we're going to be able to tell if something's a direct variation is if we do our y values divided by our x values and we get a constant every time, then it's a direct variation. And we can think of a direct variation as an equation in slope-intercept form where the y-intercept is 0, 0. You notice this is y equals kx plus b. Well, there is no b. b is 0. So it gets deleted off of there. All right? So one thing we know about a direct variation is every direct variation contains this point 0, 0. It's going to become really important that we know that. Every direct variation contains 0, 0. So what do they look like? Well, every direct variation looks the same. We know it's y equals kx, which means it's linear. It's a straight line. And because there's no plus b on here, we know that the y-intercept is 0, 0. So every direct variation must pass through 0, 0. So this one's a direct variation. But this one is not a direct variation because it doesn't pass through 0, 0. It's a straight line, but it doesn't pass through 0, 0. We could make all sorts of different direct variations. Okay, they can be positive slope, they can be negative slope. Really doesn't matter as long as they pass through the origin. They all have to cross through 0, 0. So all these lines I'm drawing, these are all direct variations. They're straight lines that pass through the point 0, 0. It's very, very important that we know that they pass through 0, 0. Over here, none of these lines, even though they're linear, even though they're straight, they do not pass through 0, 0, so they are not direct variations. Similarly, this relationship here passes through 0, 0, but it is not a direct variation because it's not a straight line. We can't write it as y equals kx. So how are we going to tell if a relation is direct? Well, three things to talk about. From a graph, as I just noticed, or as I just talked about, the line must be straight and pass through 0, 0. So we're just going to look at our graphs. We're going to say, okay, is this a straight line? Yes or no? Does it pass through 0, 0? Yes or no? It has to be both of these things to be a direct variation. From a set of values, we're going to take all of our y values and divide them by their corresponding x values. If we get the same number every time, the relation is direct. If we don't get the same value every time, the relation will not be direct. And then from a word problem, well, we're just going to make a table of values, and then we're going to do what we did for the set of values. So we're going to do quite a few examples here today, make sure we understand this concept. So it says, which of the graphs below represent a direct variation? So I should pause the video and see if you can figure this out on your own. All right, now that you've tried this, let's go ahead and figure it out. Well, we're looking at this right here, looking at this graph, and we got to ask ourselves two questions. Is it a straight line? And does it pass through 0, 0? Answer has to be yes for both of these in order for it to be a direct variation. So is it a straight line? Yes, it is. Does it pass through 0, 0? Well, no, it does not. So this is not direct. All right, let's go over here and ask the same questions. Is it straight? Yes, it is. Does it pass through 0, 0? Yes, it does. So this is a direct variation. Down here, well, let's see. Straight line, yep. Pass through 0, 0, yep. This one is a direct variation as well. We notice this one's a negative slope, this one's a positive slope. That doesn't really make a difference. The key thing is they're straight lines, they pass through 0, 0. Over here, well, this one passes through 0, 0, but it's a curved line, so it is not a direct variation. All right, so by now you should be getting the idea. Straight line passes through 0, 0, makes it direct. Example 2 says, does the table below represent a direct variation? If so, write the equation. So, we think about this. In order for it to be a direct variation, we know that it has to be y equals kx, and k has to be constant. The k I multiply x by to get y must be the same in every situation. And the way we think about this is we're going to go, okay, divide both sides by x, y over x equals k. I'm going to do 15 divided by 3, 20 divided by 4, 7 divided by 35. They all need to end up being the same number. So let's test that out. If I do 15 divided by 3, well, 15 divided by 3 is 5. 20 divided by 4, also 5. 35 divided by 7, also 5. So this is a direct variation, because when I take y divided by x, I always get the exact same thing. All right, I get a constant number. The constant is 5. K equals 5. So if I want to write the equation, well, I know the equation is going to look like y equals kx. I just figured out k is 5, so my equation is simply y equals 5x. So this is a direct variation, and its equation is y equals 5x. All right, so let's try a word problem. It says, Maddie is driving in her car. After 3 hours, she's driven 135 miles. After 5 hours, she's driven 225 miles. After 8 hours, she's driven 360 miles. Does this equation represent a direct variation? If so, we need to write the equation. Well, first thing we need to do, like in any word problem, is define my variables. What is x? What is y? Well, we've got she's driving 3 hours. She's driven 135 miles. 5 hours, 225 miles. 8 hours, 360 miles. Let's say x is the number of hours and y is the number of miles. All right. So now, in order to determine if this is direct, we have to make a table of values. Oops, that's not the table of values. That's the table of values. So we know x we're saying is the number of hours, so 3, 5, and 8. Y is our number of miles, that's 135, 225, and 360. We know that if this is direct, then y equals kx, so y divided by x is constant with a k, so I'm going to do 135 divided by 3, 225 divided by 5, 360 divided by 8, and I'm hoping that those will all be the same number. Let's figure that out. 135 divided by 3 is 45. 225 divided by 5 is 45. And 360 divided by 8 is 45. So yes, these are direct. This number here, that's k. 45 is my k. So my equation is simply y equals 45x, where y is the number of miles and x is the number of hours. So we can predict this. For any number of hours, I can tell you how many miles she's gone. And we know a direct variation has to contain the point 0, 0. Well, let's test that. If I plug in 0 for x, 45 times 0 is 0, so this does, in fact, include the point 0, 0. All right, and our final example says if y varies directly as x and y equals 15 when x equals 5, then what is x when y is 120? So this is kind of an interesting problem. It says y varies directly as x. That is telling me that this is a direct variation, so I know y equals k times x. And I know one value, or one ordered pair, y is 15, x is 5. And I'm asked, what is x when y equals 120? So I'm going to take this and I'm going to put it into a table. And you always want to put these into a table to be able to work with them. All right? We know when x is 15, when x is 5, y is 15. We know y is 120, but we don't know what x is. Well, we know that this is a direct variation. So we know y equals k times x. So now we need to figure out what k is. Well, that's actually pretty simple if we think about it. We just simply do y over x to get our k. 15 divided by 5 gives me 3. So I know my equation is y equals kx, so y equals 3x. Now, I need to figure out what is this question mark. What is my missing value? Well, to do that, I plug 120 in for y. So 120 equals 3x. Divide both sides by 3, and I get 40 equals x. So my answer is 40. So that's how we do a problem like this. It tells us that we have a direct variation here. So we know y equals kx, or y over x equals k. Put these into a table. So I organize my thoughts, figure out what I'm trying to find. Figure out what my constant of variation is by simply doing the known y divided by the known x. Plug that into the equation. Plug my known value in to find my missing value. So here is tonight's try it problem. Decide if the table below represents a direct variation. Then find the missing value. So we're going to look at this table. We're going to figure out, okay, is this a direct variation? If so, write the equation and use that to figure out what is this question mark. So you need to do this problem as the try it problem.